What's up, everybody? Jason here from PyQuant News, and today we're going to talk about speed. Not only speed, but a lot of speed. And what do I mean? Well, we're going to look at how to use two very advanced technologies within Python to save down market data and analyze it very, very quickly. And we're going to do that with a tool called Polars, which is starting to become very popular as a replacement for Pandas, and as well as DuckDB, which is an in-process relational memory relational database. It sits in process and it is extremely fast. And the coolest part that I just learned recently is that you can actually read right out of a Polars data frame. Let's see how it works. All right, first off, let's do our imports, and you need to have Polars and DuckDB installed. They're both very easy to install. I did it with no problems at all. And now let's just use Y-Finance and download some price data for NVIDIA. So what do we have? We have a Pandas data frame. Oops, prices. We have a Pandas data frame with all this price data. Okay, well, let's actually convert our Pandas data frame into Polars. Okay, so we have PL, which is Polars, from Pandas method. We're going to convert the prices data frame after we reset the index. So we move the date index out, and then we convert the Pandas data frame into a Polars data frame. And then we're going to add an alias. We're going to turn the NVIDIA column into a symbol column. Okay, so what does all that look like? This. And you can kind of see there's a little bit of a different look and feel to a Polars data frame. And you can see that this alias thing and added a, and I have a literal LIT called NVIDIA that adds this string. So here we have a 64-bit integer, a 64-bit float, and then a date time index. Okay, cool. So now that we have our Polars data frame called df, keep in mind that variable name, we're going to kind of drop into DuckDB. So first off, we want to create a connection to a database. And this can be any name, any location. I'm just creating a database called stocks. And I'm going to execute a SQL statement to create a table. And the coolest thing here is I don't have to define the table. I can create it just from my data frame, and create table, if not exists, called stocks as select star from df. So I don't have df anywhere. df is referring to my Polars data frame variable. So when I run this, it takes a split second, and I now have a database file right here inside my directory. This is a Polars database, okay? And the coolest thing is that it creates the table based on the data frame, and it is now actually populated with data from the Polars data frame. So let's look at a couple examples. You can write all the SQL you know and love. I'm not a great SQL person, but I know enough to be dangerous, as they say. So select symbol. Let's get the average closing price as average close from stocks, group by symbol. So we're going to get the symbol and the average closing price as a field called average close. Boom, and as we can expect, we have NVIDIA average stock price called $36.57. If you are better at SQL than me, you can do rolling partitions and things like that. I'm just not that great. Let's look at another example. And by the way, these are Polars data frames. We are using polars.dataframe. Inside of this method, we are calling the execute command. So if I call this outside of my Polars data frame, it just returns a Pandas data frame. But we know we can convert those into a Polars data frame very easily. So seamless change between the two. Here, I'm going to create a little bit of a more complicated SQL statement. So select symbol, date, volume, and close from stocks. Actually, this is a far less complicated one. We are just limiting a list of 5. Okay. And then finally, let's do something actually interesting. We're going to create a rolling VWAP. Okay, that's a lot of SQL. And I'm just trying to prove that I'm a little better than bad at SQL. But what is VWAP? VWAP is the volume weighted average price. So you basically multiply the price times the volume on a given day, and then you divide that by the sum of volume over time. Okay, so it's just a way to kind of get a filtered price, and a lot of people like to use it as a truer price than some moving average. So we're going to create a select statement here as the internal statement. So select date symbol. And the whole thing is right here. Volume times close divided by the sum of volume as VWAP from our stocks table, grouped by date and symbol. And then with that select statement, we create this variable called daily VWAP. And we are going to create a rolling VWAP then. So select the date symbol average VWAP over, and this is our partitioning. So we're partitioning by the symbol, we're ordering by date, rows between 19 preceding and current row, so the last 19 values as the rolling 20-day VWAP. Okay, so it includes the current day, so it is the 20-day rolling window. You can turn this to 21 if you want. And then we select that from our daily VWAP table that we just created, or variable that we just created here. And then, of course, because these are with statements, you can select all from those. And boom, we have our rolling 20-day VWAP instantaneously executed, all in a Polars data frame that we know and love. You can check out Polars here, Polar.rs, and you can check out DuckDB at the DuckDB website. Very cool technology, very fast, plays very well together, becoming very, very popular in the quant ecosystem. Hope you enjoyed. If you have any questions, leave a comment in the chat and I'll be sure to get back to you. Take care. See you next time.